Okay, I didn't want to make this video. This is just kind of because it's embarrassing, right? Because I said in a video that went out on a global stage, I said that we made so much progress with these that we were gonna potentially ship them Christmas, not the last Christmas, but Christmas before that. So these things have been delayed by over a year and a half, or no, over a year, or something like that. So this is a story of why they've been delayed, and it's kind of like a lesson to inventors not to not to be too optimistic about timeframes, because sometimes things are out of your control and the time scales blow out. So this is the story. Okay. By the way, it's launching. It's launching now in about a week and a bit. As soon as tomorrow, today's Sunday, the manufacturer's going to ship the first pilot study, first 1,000 units for launch in Australia. As soon as I get it, it's going to be available to anybody in Australia. And by the way, if you're a subscriber, we're giving these away to Australian subscribers. Okay, we just got to do a random draw. So make sure you subscribe. And they're going to be available to Australians, but they're also going to be available to anybody that wants to purchase them overseas. There might be a bit of shipping, and just as samples, right? Commercial samples for evaluation if you want to sell them in your online store. So distributors, manufacturers, if you want to integrate this into your espresso machine, because it is amazing technology, in my humble opinion. So with that out of the way, let's head into why this was delayed. Right, and the very first delay was were these legs and buttons, right? These legs firstly. So we wanted legs that kind of clip into each other and don't impinge on the espresso, right? Don't create a bulge on the espresso, and they have to clip into each other and pull apart so that you can clean the thing. Because I didn't want to produce something that's kind of disposable, and I could have done that. I could have adopted the whole give away the machine, sell the razor blades, typical business money first mentality. But I didn't want that for the JLever products, especially with the cost of living crisis, right? So it had to be cleanable and it had to be like assemblable. And to get these legs correct, there's a bit of precision involved, and it required a tool change. But that was solved last year, right? And we were ready to go. And I could have went with that. But here's the other thing that cropped up. These little buttons. Okay, these little buttons. Originally there were 5, right? They were like a 0.3, 0.4, 0.5, 0.6, 0.7, and maybe even more. But they were like, they're precision manufacturing. They take there's like plus or minus 2 microns on the filter. This is actually a laminate of three layers, right? And you can barely see it. That's how small it is. And any manufacturer can make this, but to make it cheaply, I had to kind of go back to the manufacturer and say, look, if we make this at $2 a button to manufacture, right? And there's 10 with the silicon plate, with the shipping and the taxes and everything else, and it was going to be like a $10 to $20 manufacturing cost just for the manufacturing of this little thing, right? And typically, once you get the retail, that's like everybody has to have their cut, like the distributors, whatnot, and the retailers, and it's like for such a product like this, maybe a factor of 8 or a factor of 10, which meant that this product was going to be $120 Australian, 150, and that was too expensive. I didn't want that for JLever. JLever is all about giving people a cheap espresso machine, but without compromise, right? So when you buy something cheap, you typically compromise on the build quality, on the usability, on the number of materials, number of fronts, right? I wanted to produce the best and yet cheapest espresso machine there was for people, right? Because as an inventor, you just want to bring joy to people's lives. And so it was too expensive to produce. So I went back and I said, look, we've got to make this cheaper, and they had to figure it out. And that was one of the delays. But the biggest delay was with the whole gripe that I have with the plastics industry and plastics in contact with water, even cold water. So it's an absolute no for me as an inventor and somebody that's making coffee products, is to expose you to a product that has hot water in contact with plastic, and all the chemicals that gets leached, right? I could have made this out of metal, but it was too difficult and too complex, so we had to compromise to silicon. Now, silicon is way safer than plastic. There are no microplastics, no plasticizers. There's no so phthalates, which are endocrine disruptors. There's no bisphenols like BPA, BPS, and all the variants that they come out with. There's no stabilizers, BPH, and no forever chemicals, the PFAS. Right? They're all hormone disrupting, and like the world's the kids today, the males, the sperm count is being reduced, and I think it's because of all these plastics. So I didn't want that. I wanted silicon, but I had to do the homework on the silicon, right? And here's the thing with the silicon: there's something called silicanes, which have been in Europe put on the chemicals of concern list. Okay, and there was a study done on baking trays and how if you expose silicon to temperatures greater than 195 degrees or 200 degrees Fahrenheit, then the volatiles, these silicanes, I'll call them volatiles, can come out into the food. And they typically come out into the fatty meats. Fat draws them out, right? None of those criteria are applicable to this because the espresso water is maximum 95 and there's no contact with fat, right? There might be a bit of fat from the coffee, but that stays with the plate. You need to wash it off. Regardless of that, I wanted the highest standard I could possibly get. And at each step, I was kind of pushing the manufacturer to just up the game on the standard. So the first thing was, we got to get a resin. That's like the best quality resin. That's medical grade. And that was, the resin is Wacker, Germany. They're headquartered in Germany, huge firm, very, very competent, very reliable. I trust them, I guess, implicitly. They've got an arm in China, so they've supplied us. But the waiting time for that resin was like, a month and a half. So that was another delay. And then changing over to resin midstream, and changing the degassing procedure, because in that study that I read, the volatile elements, and by the way, the Wacker resin, which is a medical grade resin that we chose, has very low volatile elements to start with. Okay, but there's an extra degassing procedure that I demanded because I read it in the paper. And if you degas it at 200 degrees Fahrenheit silicon, then all the majority of the volatile elements get driven off. Okay, so they're not coming out in your coffee. Very low to start with, but I wanted to drive them off, and that shrunk the part, and so we had to change the tool once again, right? And you change the tool, it's a month or a few weeks to change the tool, and you got to evaluate the parts once again. So in the end, Wacker resin. I also wanted to change at the very last minute the actual, and I can't believe that my manufacturer was so patient with me. They were great, by the way. I wanted to change the way the silicon is. What is it? Hardened. I can't remember what the term is. The catalyst, because the first sample plates are with peroxide catalyst, but it's not as clean as platinum. So the main production one's going to be with platinum. The peroxide still passes all the standards, but the main production one is going to be with platinum curing. That's what it's called. And lastly, I demanded that this thing pass all of the standards, all of the highest standards in the world, food grade standards, not medical grade because it's not applicable, right? So it's not appropriate, but food grade standards. So there's the German one, Japanese, which are the highest, and then there's American, which is not very high, right? So that's why I got delayed, because I wanted to make sure that, number one, it was inexpensive to produce for people, and it didn't leach any kind of chemicals into your coffee, right? I mean, the poison is in the dose always, and we're exposed to silicanes on a daily basis. They're everywhere. They're in makeup. But it's, I didn't want to contribute to that dose of silicanes that people take in their daily life. Okay, so that was the reason for the delay. So I really hope you're excited about this, as I am. I'm so tired because there's so much to do when you start a business, and yeah. But I hope you're going to be excited. Okay, thanks for listening.